So let's get the presentation started with Arnold and the sky this month.
For the sky this month, I'll cover the period from tonight, May the 4th, through the end of the month. Did I just say May the 4th?
May the force be with you.
May the force be with you.
May the force be with you.
That's right, it's Star Wars Day, and with that in mind, here are the highlights for May 2022. Mercury is visible in early May. Acrid meteor shower peaks tomorrow morning. The following night is our Millennium Square stargazing party. There's a total moon eclipse on the 15th. There's a Moon-Saturn conjunction on the 22nd, a Moon-Venus conjunction on the 27th. Jupiter and the Moon get close pre-dawn on the 29th. There might be a new meteor shower on the 31st. And there are globular clusters, open clusters, galaxies, double stars, and comets to see this month. You're right, R2-D2. There's a lot in the sky this month. As we explore what's in the sky this month, I'll be referring to deep space objects, double stars, and moon features that are included in these 5 RASC observing programs for both beginning and intermediate level observers. Now, the RASC offers a second, more detailed moon program and 2 advanced deep space programs as well. And the one on the left, Explore the Universe, is the ideal starter program for those new to astronomy, and it's also open to non-members. If you download the observing list for these 5 programs, like this list for the double stars, you'll have the info needed to locate the targets I'll be mentioning tonight. For example, you'll find the RA and DEC coordinates, the constellation they're in, what season to look for them, and so on. In your browser, if you search RASC programs, you should find visual observing programs at or near the top of your results. As for observing our targets, our night window to see them in is shrinking this month by an hour and a half, from 5 3/4 hours at the beginning of the month down to only 4 1/4 hours by month's end. Night begins, let's just call that 10:30. That's when the sun is at least 18 degrees below the horizon. So that would be around 10:30, the beginning of the month. We'll have to wait till 11 o'clock to see full darkness by the end of the month. But fortunately, the planets are visible in twilight. In fact, you're going to need twilight. You're going to need twilight here at the beginning of the month for seeing Mercury before the right after the sunset. And then throughout the month of May, you're going to want to use this window before sunrise to see all of the other planets as they're beginning to rise higher in the east before the sun rises. As for darkness this month, the darkest nights will be from tonight through this weekend, including Millennium Square at Pickering at the foot of Liverpool Road. That's on the 6th or 7th. And then darkness comes back at the end of the month for the last 7 nights and into the first week of June. If you start your observing facing west, you have a chance this weekend to catch some of the late winter treats before they set, like these open clusters in the outer Orion arm of the Milky Way from Gemini to Cassiopeia. Once they set a third of the way up the sky, we can find the large and bright open cluster M44, Messier 44, also known as the Beehive Cluster. And this weekend, it is visited by the first quarter moon. Here we see it as it will be on Saturday night, passing just 3 degrees from the cluster's center. The beehive is 1.5 degrees wide, so it's best viewed in binoculars or through a small telescope under low magnification. It has at least 1,000 member stars, of which 30% are sun-like. Those would be spectral classes F, G, and K. In 2012, 2 hot Jupiters, or hot gas giants, they were discovered orbiting close to stars just like our sun in that cluster. Now, the double star program includes 83 Leonis that you can split easily with any size telescope. You can find its location in southern Leo by extending lines from Epsilon to Beta Virginis, and from Delta to Theo Leonis, and aim your finder scope where the lines cross, and the brightest star will be magnitude 6.5, 83 Leonis, and this double star will split easily in 50 times magnification as seen here. The brighter of the two is a subgiant just off the main sequence, on its way to becoming a red giant and eventually a planetary nebula. The dimmer component is an intriguing orange dwarf. It's a clay-cast main sequence star. K stars have masses from 50 to 80% of our sun, and they are of particular interest in the search for extraterrestrial life due to their stability and long lifespans. In fact, in 2005, a gas planet twice the mass of Uranus was discovered in a 17-day orbit around that star. Facing south now, we see that springtime is galaxy time as the spiral arms of our Milky Way hang low near the horizon, and the North Galactic Pole, our window into intergalactic space, reaches the meridian on spring nights. So this makes this a great time to hunt for galaxies. There are thousands lying in and around Leo and Virgo. For example, east of Leo's tail is where you will find Markarian's chain. 8 galaxies discovered in the 18th and 19th centuries, 2 by Charles Messier and the others by William Herschel. They are known as Markarian's chain after the Armenian astrophysicist Benjamin Markarian discovered their common motion. He did that work in the early 1960s. And this Markarian's chain lies within the vast Virgo cluster of 1,500 galaxies. The center of this cluster is about 54 million light years away. Now, with a 200 millimeter or 8-inch telescope, 32 or so of its member galaxies of magnitude 12.5 or brighter are within reach from a dark location on a moonless night. And of those 32, 16 or half are Messier objects ranging from 9.3 to 11th magnitude. The best known of these would be M87, the galaxies whose black hole was successfully imaged in 2019 by the Event Horizon Telescope. That's an array of antennas, radio antennas across the Earth, giving us the effective aperture, the width of Earth. And this is how the galaxy would look in a 200 millimeter telescope at 114 times magnification. Now, if you are out past midnight, you'll see the bulge of our galaxy's core beginning to rise in the southeast. And because globular clusters swarm in a halo around the Milky Way's nucleus, as that nucleus rises, it brings globulars up with it. And here are 3 that are bright and easy to find. Extending a line from Gamma to Beta Coma Berenices, or looking halfway between Cor Caroli and Arcturus, you will find Messier 3, the first Messier object discovered by Charles Messier himself. The globular cluster has 500,000 stars, and more variable stars than any other globular we know of. And as you can see, M3 appears quite removed from the nucleus of the Milky Way. And in fact, it is quite isolated. It's about 31,000 light years above the center of the Milky Way, and coincidentally nearly the same distance from Earth. And because it is so high above the dusty plain of the Milky Way, it shines brightly at magnitude 6.9. In a 10-inch telescope, the central wall of light is 6 arc minutes wide, with a halo of stars doubling its size. Now, a line from Tau to 100 Virginis points you to M5, discovered in 1702 by Gottfried Kirch, a German astronomer. This cluster is over 13 billion years old, nearly as old as the universe itself. Some estimate that the cluster's population is around 500,000 stars. Now, at a distance of 24.5 thousand light years from us, it's actually 20% closer than M3. So it shines a half a magnitude brighter at magnitude 6.4 and appears larger. It's an excellent globular cluster for amateur telescopes. Now, if you are out late enough to see the constellation Scorpius rise, you can spot one of the southernmost of the globulars in Messier's list, M4. immediately west of the bright star Antares. It was discovered by Philippe Loys de Cicero in 1745 and catalogued by Messier 19 years later. It was the only globular cluster that Messier was able to resolve into individual stars because of his small scope. Now, M4 is possibly the closest of the globulars to us. It's only 7,200 light years away. Compare that to the 20 to 30,000 light years that are typical for globulars. M4 has a relatively loose concentration and a low population for a globular with only 20,000 stars. It has lost most of its stars when passing within 2,000 light years of the center of our Milky Way on a very elliptical orbit. So each time it passes near the core, it would lose many of its stars. But because of its proximity to us, M4 is very bright at magnitude 5.6, and it appears slightly wider than the full moon. Antares, the star next to it, is a fascinating target too. It's a red supergiant at the end of its life. If placed in the center of our solar system, its photosphere would extend beyond Mars, and the upper chromosphere would reach nearly to Saturn. Like Betelgeuse, it's about to go supernova, but it's 550 light years away, so we're safe. Here's a view facing east as darkness falls this weekend. The constellation Boötes is halfway up the eastern sky by 11 o'clock. The double star observing program includes Delta Boötis, the easternmost star in the familiar kite-shaped pattern. If you can split the star into its two components in any size telescope operating at modest power. The brighter star is G8 orange-tinted giant star, currently fusing helium into carbon in its core. Its companion is a main sequence class G star, and it's actually very similar to our sun. When observing it, you can consider that this is how our sun would look like, the smaller dot. That's how it would look like in your telescope at a distance of 112 light years away. These two stars are moving through space in lockstep together, so they appear related. But at a physical separation of 3,800 astronomical units, if they are gravitationally bound, it would take 120,000 years to complete one orbit around each other. And if you are out past midnight, you'll see Sagittarius, that arm of the Milky Way, rising. And that was, currently hugging the horizon at night. Well, now it's beginning to rise till later we get into the night. And some of our summertime favorites are climbing into view, like Cygnus the Swan. You'll notice the Milky Way runs right through Cygnus, which gives you a lot of deep space targets to choose from. And the finest NGC program includes Open Cluster NGC 6819, nicknamed the Foxhead Cluster. And it's found about 2/3 of the way from Beta to Delta Cygni. The cluster contains 150 member stars, ranging in magnitudes 11 to 15. It's 5 arc-minutes wide, nicely concentrated, and well detached from surrounding stars, as you can see here. The brightest stars form a ragged V that seems to frame the cluster's fainter stars, suggesting a fox head to some, and I can kind of see that. There would be one of its ears, and there's the other ear, and its nose, and its eyes. So yes, I can see a fox head shape in that. This cluster lies 7,200 light years away, and that is similar to the distance we saw for M4. And facing north now, we see Ursa Major near the zenith, just after sunset. And his tail gets very close to the zenith around midnight. Next to the tail, the Whirlpool Galaxy Messier 51 reaches an altitude above 86 degrees as seen from Toronto. That's nearly straight up. So you are looking through just one atmosphere. That makes this your best opportunity of the year to observe, sketch, or photograph Messier 51. The galaxy and its satellite companion NGC 5195 are easy to find. They're just 3 degrees southwest of Alkaid, and that's the star at the end of the Bear's Tail, or the star at the end of the Big Dipper's handle. And that's center of the M51 is very bright and white, not the dull yellow color we often see, like the yolk of an egg in the middle of a spiral galaxy. This is whiter and brighter because of a lot of starburst activity triggered by its companion as it orbits around. Under dark, moonless nights, it is possible to glimpse this pair with binoculars. I once did that outside Bruce's Mills, north of Toronto, if you know that area. But that had to be at least 25 years ago. I don't know if I could do that there now. On the opposite side of Alkaid, 5.5 degrees north, is another face-on spiral, M101. That was discovered by Pierre Marchand in 1781. The Pinwheel Galaxy is slightly brighter, but is actually twice the angular size of M51, so its overall surface brightness is dimmer, making it a bit harder to see. Well, that's the end of the background music. Just thought I'd throw that in for fun while we explored intergalactic space. So let's look now at the solar system this month, starting with the sun. As you just saw, the sun climbs 5.6 degrees from tomorrow to May 31st. And at 68 degrees high, we're looking through just 1.08 air masses. And that means May is the beginning of a prime time for observing or photographing the sun and getting good detail. Here's an impressive sunspot taken by Claudio Oriani 2 weeks ago, showing sunspot activity for solar cycle 25. Active regions with multiple sunspots can produce M and X class flares and CMEs that produce auroras. Flares and ejections, they will occur when sunspots with strong and opposite polarity develop side by side, like these examples. Active regions with close and opposing strong magnetic fields, like we see here, are called delta class. And in this colorized magnetogram, we can see active region 3004 as it begins to rotate into view. And as it rotates, it becomes a little bit more developed. You can see the sunspots getting larger and brighter in color, indicating a lot of strong activity. And here we do have a delta region having developed with red and blue spots close together. The reds indicate polarity racing away from us, field lines racing inward towards the sun, and blue spots would be heading towards us. And in that particular region, we did get a M-class 5.7 flare in this active region 3004. It brushed by Earth at the end of April, and we're going to keep an eye on spots like those. You can also you can keep an eye on auroraforecast.com, and if you visit that website, they'll give you the outlook for the next 3 days to see if there's the likelihood of any auroras. You can also visit spaceweatherlive.com and take a look at their colorized magnetogram images looking for delta regions. And if you find them, you may be able to predict auroras yourself. Now, the moon is at apogee tonight, reaches first quarter this weekend, then becomes full and totally eclipsed on the 15th. There are favorable librations on the 16th and 18th as the moon passes through perigee. Third quarter on the 22nd, and May closes out with another full moon, a new moon, excuse me. The Explore the Moon observing program identifies targets with moon maps. Targets are grouped according to the terminator's location. This globe shows where the terminator runs on the indicated nights before, negative, or after, positive, first quarter, which is considered 0. That is, first quarter moon is Q day 0, and when it's best to observe along the moon's central meridian. Now, Q0 occurs this weekend, and here are two features you can examine. Item A, Valles Alpes, or the Alpine Valley. That is a slender 166 kilometer long depression that runs northeast from Mare Imbrium here to Mare Frigoris up at the top. This is likely a graben. A graben is a sunken block with parallel fault lines on either side, as we see here. Later, when Mare Imbrium welled up with lava, some of it flowed down this valley and hardened. Another object you might want to check out is number 28 on this list, Arzakel. Arzakel is a fresh, young crater with unbroken, completely circular terraced walls, a central peak that's over 1.2 kilometers, or is 1.2 kilometers high, casting a great shadow at day Q0. And right beside it is a 10-kilometer moon. A fresh 10-kilometer crater, a young crater that is on the floor of Arzakel. And maybe the highlight of the month is a total eclipse of the moon on the night of Sunday into Monday, May 15 to 16. The umbra of Earth's shadow takes its first nibble out of the lunar disk at 10:30. Here we see the position of the moon when it just begins to touch the umbra at 10:30 p.m., just at the start of night for Toronto. So Canada, from Toronto on east, will see the eclipse during night. West of Toronto, some or all of the eclipse will be occurring in twilight. The moon slips completely inside the umbra for totality an hour later at 11:29. And then the blood red moon will stay within the umbra for 75 minutes. That gives you a long opportunity to observe and image the colorful moon and the surrounding stars that will pop into view. The entire eclipse is visible east of Thunder Bay and occurs during the night from Toronto on east. Further west, the moon will rise in the Earth's penumbra or umbra, or rise fully eclipsed west of Kelowna just as the sun is setting. So in other words, how much light you will have to deal with during the eclipse will depend on how far west you are. Because the moon will be low as it's entering the umbra, as it's still rising, you might be able to incorporate a foreground scene into a photograph of the eclipse. On to the planets now. Starting with Mercury, which you can still catch for maybe the next 10 days as it heads for inferior conjunction on May 21. Tomorrow evening at 8:45, when the sun is 4¼ degree below the horizon, Mercury will still be 12.8 degrees high in the west-northwest, around 20% illuminated as suggested by this picture here. If you like to image Mercury, this might be your last chance to capture it in a thin crescent phase. If you can magnify it enough and you have steady air, you're fortunate enough not to have turbulent air near the horizon. Now, over the next 10 evenings, its brightness will drop by 2 magnitudes as its crescent phase becomes increasingly thin. And so by the 14th of May, it'll be so thin, it'll be so close to the sun, I would be surprised if you can still pick it out. All the other planets are in the east before sunrise. By 5 a.m. tomorrow morning, Venus will have risen and will join a stunning lineup that includes Jupiter, Neptune, Mars, and Saturn. Of course, you would need a telescope to see Neptune. And as we step through the rest of May at this hour, notice 3 things. The gas giants, Jupiter, Neptune, Saturn, and eventually Uranus, are all climbing to the south as we orbit underneath them. Venus is going the other way as it races away from us on its orbit around the sun, and Mars remaining at the same altitude as our orbit takes us directly towards it this month. You may have noticed the moon slipping by this lineup. On May 22, the moon is 5 degrees from Saturn, close enough for the pair to be captured in the DSLR with a 200 millimeter lens. And then 5 mornings later, the 26-day-old moon rises 3 degrees behind Venus, and that's close enough for a picture with a 300 millimeter lens. And on the 29th, you can catch Jupiter and Mars so close together as they rise, just 35 arc minutes apart, that you can catch them together in a telescope. There are 2 comets, C2021-03 and C2017-K2, both discovered by the Pan-STARRS telescope, and they'll be tracking across the north and northeast, and you might like to try and hunt them down. And here are their locations at UT midnight for the remainder of May. Each dot shows where they will be at UT midnight this month. And because 2021-03 is around a quarter as far away as 2017-K2, it travels further per night. I think it's incredible, actually, to think that both of these comets are pristine Oort cloud cast-offs. They both took at least 5 million years on hyperbolic trajectories to make their once-only perihelion slingshot around the sun within a year of each other. That's kind of an amazing coincidence. Now, 2021-03, it already passed the sun closer to Mercury, and that was 2 weeks ago, and it's already on its way into interstellar space as it spends the next 3 months in our circumpolar region. There are no recent magnitude estimates for the comet in the observer's database because this comet has just returned to the night sky. But optimistic articles suggest it could become magnitude 5, or at least be a bright comet in binoculars, a bright binocular comet. The other comet, C2017-K2, it was pegged at magnitude 10.3 9 days ago. So it should be getting brighter as it comes half an astronomical unit closer to us and closer to the sun as well throughout this month. The Hubble Space Telescope was able to image C2017-K2 with its wide field and planetary camera when the comet was still beyond the orbit of Saturn. The comet was already producing a coma, but it's way too frigid that far from the sun for water ice to sublimate. So that tells us that this is a pristine leftover from the solar system's formation, with the coma being produced by primitive volatiles like frozen nitrogen, carbon dioxide, and carbon monoxide. The Eta Aquarids meteor shower peaks tomorrow morning. Its radiant next to Eta Aquarii clears the eastern horizon after 3 a.m. with no moon interference. According to NASA on their solar system exploration website, they say we can expect to see around 10 to 15 meteors an hour, and that's actually quite excellent for a radiant so low in the sky. This shower is known for the speed of its meteors, which is debris from Halley's Comet. With the radiant rising in the east in the morning, we are traveling straight at it in our orbit, and our orbital speed is 30 kilometers a second. And the debris from Halley's Comet is traveling around 33 kilometers per second in retrograde. So it's a true head-on collision, with meteoroids becoming meteors at 66 kilometers per second. I believe that's the second fastest of all meteor showers. And those produce quick and brilliant streaks. And you can also watch for the Eta Aquarids any morning that you are out enjoying the parade of the planets in the east, because this shower will run until May 28th. Comet 73P Swassmann-Washman 3, also known as SW3, is the parent body for the Tau Herculids that peak in early June. It's a Jupiter family comet on a 5.4-year orbit, and during its 1995 perihelion, seen here, it fragmented into 4 main bodies and has been disintegrating further on each perihelion since. During its 2006 flyby, the comet had broken into 66 pieces, and this video shows the continued breakup of one of its fragments. Now, independent studies in Germany and Japan independently concluded that there is a good chance our orbit will take us through some of the debris from that initial 1995 breakup. Notice how narrow the window is for the peak. It only runs from 5 to 6 UT on the morning of May 31st. In fact, the meteor shower and its peak is all there in that 1 hour. If we do intercept those fragments. So if it does happen, those hours translate to 1 to 2 a.m. our time on the 31st, when the proposed radiant in Boötes is high in the west, and there will be no moon interference. Now, unfortunately, it's in the west. That's the direction we are orbiting away from, so we would have to subtract 30 kilometers per second to the speed with which the comet's fragment pieces hit us. And so it might be slow moving, not so bright meteors, but here's hoping that it happens. So with that, I will end my presentation and ask if there are any questions.
Arnold, that was a fabulous presentation. Thank you so much. You did a really thorough job presenting the sky this month. Thanks again. Let's go to Emma. Any questions for Arnold?
Yes, first question coming in from Keith. He says, I'm trying to discern the background music. Is it John Williams?
Yes, it is. I had a brief display of the title of those pieces along with his name to give credit.
Great. We got a question from Lewis. How large are the SW3 fragments?
I don't have answers for that, I'm afraid, but they would. Okay, they're going to be from microscopic little dust pieces, but how big the bigger ones are? Okay, I'll hazard a guess, the size of a bus, maybe? I don't know if they're going to be anything like hundreds of meters large anymore, because they've been breaking up constantly on each orbit, but I'm afraid I would have to investigate to come up with a better answer. I could throw it out on the forum.
Great. Next question comes in from Leo. Regarding the lunar eclipse, will it be clear?
Yes, I guarantee it, because it's my birthday, and I put it in an order for it to be clear. So yes,
that's great.
No two ways about it. Just as nice as it's going to be this weekend.
Cool. Well, that's all of our questions for tonight.
Oh, great. Well, thank you.
Arnold, before you go, I have a question myself. The field on slide 13, is that a real place or is it a rendering?
Slide 13, let me jump to it.
You have a nice field.
Yeah, that is, that would be Starry Night Pro.
Mm-hmm.
In this show, you would have seen images generated in Starry Night Pro and Stellarium Plus, which is available on Androids only.
Okay.
Yeah, very good products. What Stellarium has done lately is interesting.
So that field is rendered. It's not real.
Correct. Starry Night Pro.
Okay. The reason I was asking is because I seem to have seen a lot of piers, telescope piers, scattered throughout. That's
right.
What I saw.
Yeah, this is one of the choices for landscape. It's an observatory, I believe. Something
okay.
Like that. Yeah.
Very good. So it's not a real place.
It is. It's taken somewhere and then imported into Starry Night Pro for use. It's an actual photograph of a location. Yes.
Oh, I see what you mean. Then it's a real place, and perhaps those are real telescope piers then. Wow.
Yeah, it's a real place, and those would be piers, I suppose. They look like they've got power on the sides, and so on. Yeah.
An observer's dream. Very good. All right, Arnold. Thanks again.
You're welcome.
Appreciate it.